All right, so I'll be recording this lesson in the camera. The only thing that's coming out, let me just take that, is camera on elbow. All right, not anymore. You're not coming out. So just so you know that you're not coming out, all right? But the lesson is being recorded. So if you were to ask a question or I were to direct you to pay attention, know that you'll be, in the recording. That I will then share with your classmates. All right? Hopefully it works. Okay, so I know you guys were not here yesterday. So in yesterday's lesson, we were introduced to solving inequalities. All right? Solving inequalities is just like solving a normal equation. You're still using all the skills that you learned for solving an equation when it comes to an inequality. The only difference is the way you write your answer. And I show you that in today's backward. All right? Now, I am teaching, and from now, I only have Axel, Cameron, and Liliana looking me forward. The rest of you should be looking this way, right? Okay? So, in today's lesson, we're going to be solving compound inequalities. Okay? So, for the backward, we solve one inequality. Compound inequalities, you're solving two inequalities together. All right? And you're finding the solution between those two inequalities. Okay, so the table here below, as I mentioned before, it tells you the signs that you're going to be using when writing your answer in interval notation. So when you have this symbol, such as the greater than or the less than, you will represent that with an open dot in the number line, and you will use parentheses in the interval. When you have the greater than or equal to, less than or equal to, you will use a close dot and use brackets in the number line, okay? This means that that number is part of the solution set, right? It's true for that inequality. Versus this one says that the number by it is not part of the solution set, all right? Whenever you have the infinity, the positive or the negative, you will always use parentheses, okay? When you're writing the interval. Now, in here, I'm telling you about the two types of compound inequalities that we're going to work. We're going to work with what is called a union and with an intersection. For the union, you're looking for the solution set of both inequalities, all right? So you're going to take all the elements, all the numbers that make both inequalities true, except those numbers that repeat, okay? For the intersection, which kind of makes sense in the name, at least to me. Intersection, you're looking for the solution set that they both share. So the things that they both have the same, right? So the union, I want the answer for both. The intersection, I only want the answer where they both meet, what they share, okay? Make sure you know both difference. Any questions so far? All right. Questions? No? Nada? Okay. So in here, me trying to show you a visual representation of what this means right here. I want the solution for A and B, but I don't want the ones that repeat. Okay? Not repeating. I just want where they both meet, what they both share, which is in the middle. Okay? This right here is the symbol that we use for the union. This right here is the symbol that we use for the intersection. I used to like to think about it, happy face, that. But if you don't like it, just know that union, intersection. Okay? Now, to help you understand that, at least with the numbers, without actually having to solve the inequalities, I have this example. Okay, we want to find the union and the intersection of these three sets. All right, so you have a set, it's a list of numbers. Okay, these little things right here are supposed to be braces. I cannot draw braces. I do a parenthesis bracket, but the braces, they don't come out right. All right, so this tells you for part A, find the union between A and B. I want all the elements that are in A and B, but if they repeat, I'm only going to write them once. Okay? So this tells me I want all the elements that are in set A and in set B. Okay? The A, set B. I have the letter A here and the letter A here. Do I write it twice or one time? I need B, because they want all the elements, right? I have two C's. Do I write it twice or one time? Then I need D. I'm going to write E, right? Only once. I need F, G, I, and K. I want all the elements that are in set A and in set B, but if they repeat, I only write them once. That's what the union tells me, okay? That's what I'm looking for. Any questions with that? Does that make sense? What about B? I mean, 2. No, what is that? Yeah, B. The intersection between A and B. What are the numbers that they both have the same? I mean, what are the variables that they both have the same? A, C, and E. Does that make sense so far? Oh, my goodness. Yeah. I don't see you writing. All right. What are the numbers that set A and set C have the same? I mean, what are the letters? What are the letters? Tell me. Anything they share the same? No. This is called a empty set. Ooh, that is that. An empty set. And you simply just put it like that. All right? There's nothing in common between the two sets. Nothing where it intersects. Okay, so this is an empty set. Wait, I'm writing empty wrong. How do you write empty? E-M-P-Y. Oh, okay, so I was not writing it wrong. It's just here. Where?
The A goes after the E.
This A goes here?
Yeah.
Oh, and you tell me now? Now, after I'm already recording? What is that? So not here. Oh my goodness. Now I forgot the rest. What is it? 2 piece or 1 piece? The P team. B, D, C, all right. Okay, now that I'm looking at it again, makes a little bit more sense. Repeating. Any questions so far? The whole part of this right here is for you to understand that when you're dealing with a union, you're looking for the solution set of both inequalities. Okay? When you're dealing with an intersection, you're looking for the solution set that they both share. Okay? You're gonna see several examples in Inequalities, but you're gonna have to graph it and see the lines. Okay, it's a union. Where are they going? What is part of the solution set? Okay? I know. I know. Yesterday was rough. And then last night, my baby boy, he seems to be, I think his teeth is coming out or something. I'm not sure. But he was not having a good night. So I'm moving and moving and moving. Oh my goodness. This morning, my husband, he's like, you should call out. And I'm like, no, can I do that? Oh. Getting you guys to where you are, a year old run and healthy, pretty hard. I'm sure you guys are super, super, super loving to your parents because it's hard, some hard work to make you guys be all grown up. And it's like you're feeding a child that doesn't want to eat and you're hungry, but you gotta make sure they eat. When you haven't ate, not an easy job. Anyway, so we're gonna take the inequality and we're gonna solve it. Let's keep in mind when we're talking about a union, all right? This symbol right here, the union, the U, okay? We're talking about an and statement. And we have the intersection, we're talking about an or statement. Okay? For some reason, last year, I got really confused with something. And I remember making a mistake and then having to tell the students and confusing them really bad. And I believe I didn't catch that mistake again. So let me double check something. I just saw the board and something just said, wait a minute. Something might be wrong. What section is it? 1.5, right? Oh, there's so many examples I haven't looked at yet. What am I even doing? What is with this brain? Making a mistake over and over again. Cannot get over it. All right, so make sure you correct this. This is or. And this is and. All right. So for the union, you want the solution set, whether it's for the first inequality, the second inequality, or both inequalities. And I'm not there, you want the solution set for both of them. And you will see that in the examples. For the end, you're looking for the intersection of both of them, okay? And you will see that the moment you graph them, you will know what solution it is. That's why doing the number line is so important, because it gives you a visual representation of what you have. Okay? So for every question, I'm going to ask for a number line. Okay? So I'm going to take these two inequalities and I'm going to solve them separately. I got the number. Okay? Just like a regular equation. Okay, give me one tiny bit. We're missing a number there. And the number is number 8. Do you notice that there was a number missing or you guys didn't know? Right? Because how, it not would have just been 0, but I would have wrote down 0. Okay, so I'm going to take the first side and I'm just going to solve. Normal, like a normal equation, but this have the symbol of the inequality. I'm going to take the second inequality. I'm going to solve. And this gives me 7. Right? Now, step 1, solve the inequality. Step 2, draw your number line. And you're going to put both answers. And this is why we're dealing with the compound inequality. Before it was just one answer. Now we're dealing with 2 things. Okay? So I have 1 over here, 7 over here. I know that this is negative infinity. I know that this is positive infinity. Okay? For this symbol, am I going to have an open or a closed graph? For this symbol, open or closed? Now let's see. X is greater than 1. Which way? X is greater than 7. Okay? So both arrows are going to the positive side. Okay? We're dealing with an end statement. We're looking for the intersection between the two inequalities, where both elements are going to be the same. All right? Between 1 and 7, do the two lines overlap? Huh? Do they, like between 1 and 7, are they on top of each other? No. At one number, do the two lines start overlapping? At 7, and I always be left to right. Okay. Where are both lines going? And what is that? Positive infinity. At 7, open or close that? Close, right? And that means I have a bracket or parentheses? Bracket, all right. It's okay. Positive infinity gets a now. If this would have been an OR statement, a union, all right, where you want the solution for both inequalities, the interval would have been different. If this would have been an OR statement, it wants the solution for both this one and this one. So it would have been from 1 to positive infinity because it wants the solution for both of them, right? So knowing what the and or the or means, it was going to help you to determine what solution set is that you're looking for. All right? Any questions? And we have 2 minutes. I'm going to give you time for you to take everything that we have learned, finish your notes from yesterday, because if I'm not mistaken, you guys didn't do them. And ask me any questions that whatever doesn't make sense, right? There are many more examples that you will be exposed from compound inequalities that we're going to be working on, right? I just didn't want to do so many in the lesson, and look at what is this? Okay, this is not Marcus. Marcus? No, right? Marcus? Yep. Marcus, yes. Marcus is tired. You're sleeping? Tired? Bored? All right. So how do we stop this recording? Stop recording.